So, hello and welcome to another episode of Flying High with Flutter. I'm your host, Alan Wyma, and today we have a great guest to talk about something very important. I think I've mentioned quite a few times on the podcast. It is Laurențiu Spilcă. He's the author of Software Security for Developers. Laurențiu, it's great to have you on. I'm always a huge proponent of security, up until the point where it becomes maybe a little bit too much. But then the question is, how much is too much? It's kind of a relative thing. For instance, I'm actually working on a project right now where like every 8 or 10 hours, but somewhere between 8 to 12 hours, I get logged out, which is okay, fine. But I have a YubiKey I have to always keep touching. So I call it the YubiKey aerobics, where every day I have to reach over, touch. You got to log into email, touch, log into Slack, touch, log into all these different things, touch. But once you do it once, it's pretty much okay until you do another service. But email, Slack, and then there may be one or two other things, and you're basically done for the day. But like I said, for security, it's fine, makes sense, right? But there does become a point where it's too much. But so far, this is not too much. But it's better than having nothing, right? Which is the most dangerous part. And I think a lot of people treat security as like an afterthought or something towards the end. Let's kick it towards the end. But there's stuff that you can always implement at the beginning that I think is super important. But we can obviously talk about that later. Let's talk a little bit more about you. Do you mind to do a quick introduction of yourself?
Thank you very much, Alan, for inviting me here. Hi, and thank you for the audience here listening to us. I'm Laurențiu. I'm working as a consultant in software development and architecture for many years already, and I'm particularly known in the Java Spring community and with security and software security implementations. I'm writing now together with a friend this book, Software Security for Developers, but this is actually my fifth book. So many others know me for other books such as Spring Security in Action, for example. I think this is the most known of the books that I've wrote during the past years. I'm involved in many projects, and I've been involved in many projects on short and long term throughout the past years. And I can say that I got enough experience, and I've seen good things and bad things at the same time. And yes, as you say, software security can be annoying sometimes. Whether you're asked 3 times for your authentication code, or you have to wait for that OTP to arrive so that you can log in and stuff like that when you're hurrying. But without it, trust me, consequences might be severe. So we have to think that these kinds of protection exists for us in the applications, because if it wouldn't, well, we've seen news in the media with companies and individuals being affected dramatically by vulnerabilities, whether this is theft of data or why not money in the end. We don't want to get into that.
Yeah, I saw you listed some. It's at the beginning of the chapter about making sense of application security. You start to talk about, this company was fined that much, that company was fined a lot. What was it? The average amount is like $3 million per like security breach, right? That's a lot of money.
Yeah,
even for a small company.
We discussed about millions of dollars usually, and if we take only the money, but in many cases it's not only the money. The most a company might lose is the image, their brand, because when you hear that company X lost the data of their customers, that may include sometimes, I've even seen sometimes unencrypted passwords or private data such as identification codes and even email addresses. They lose trust in their clients and then they lose not only money, but they lose their clients, they lose value on the shares on the stock exchange, and so on and so forth. So when we say the company lost a few $1 million, and we only refer to the money they lost because they were fined by, I don't know what administration, that's only part actually of what they usually lose. That's only the short-term loss, but there is a medium and long-term loss as well.
Yeah, and because usually the truth does come out, especially a lot of these companies that have to pay lots of money or they have lots of customers. Usually they're like, what do you call that? They're publicly traded companies. Even if they're not publicly traded, they still try to be open because people start asking questions, especially if if you lose customer data, right? They want to know what happened, right? Why? How can this happen? And then, if they find out, oh, they didn't upgrade something or they didn't care about whatever. I mean, it's hard to rebuild that trust, right? I saw you talked about you have to have that these companies employ like a CISO. I'm not too sure how. I mean, I know a little bit what a CISO does, but I'm kind of curious about how a CISO can even help to, like at all levels, make sure that you have the right stuff. What comes to my mind is I remember quite a few years ago there was this Log4j vulnerability that happened, and you're smiling, right? Because I'm pretty sure you know what I'm talking about.
December, yeah.
Yeah.
We all know that December, so it was nearly Christmas. So some of us had to work on the Christmas day because of that. We will never forget it.
What I want to say is like, would a CISO actually able to solve that? Because there becomes a point where it's like no matter how many CISOs or how many levels that you have, at the lowest level, let's just say in development, the lowest level is like a developer, maybe a tester. I mean, to me, I guess you can put them on the same level. I mean, a tester probably doesn't test to see what version of Log4j you have and this kind of stuff. But a pen tester would be doing this kind of stuff. But coming back to like a developer, let's say they know they have to upgrade. I mean, it's also the same thing as like say like a janitor cleaning staff leaves a window open and somebody comes inside, right? At what point and how can a CISO help with this kind of stuff, with this kind of low level stuff that people like do the wrong thing that is like way out of their line? Would it be implementing, say, something like okay, you have to go through like a scanner that will then scan to see what dependency you have updated and run this against a CVE list? Do you have any ideas on how a CISO can possibly solve this kind of problem?
Yes, there will always definitely be ways and things that you do not see. However, a director or an executive has plenty of tools they can apply to minimize these risks. And some of them imply ways of working, a combination of ways of working with employing the needed experts and allocating enough time for the development and for applying those practices. We have tools and ways that we have defined throughout the times that we can include to automatically check our dependencies or to validate how our dependencies integrate with the software that we build. And they are directly integrated in the development flow and in the software architecture. The problem is that in many cases, directors and executives tend to look too much on the money side and cut corners, which basically may lead to more risks in terms of security. So they take a risk, and some of them they do not properly understand the risk that they are taking. What if I'm not checking for the log4j dependency? How could that hurt me? Well, we have seen, as you said years ago, that even a simple small dependency that looks totally unharmful, such as log4j, which for those of you watching us who don't know what log4j is for, it's like the name suggests, a simple library for logging, for putting logs on a stream to store them in a file or in a database or in the console. That had this vulnerability that basically allowed would allow hackers to go into the system and execute commands on the operating system or the virtual machine where the software was running. So very, very bad. I would say, and my advice for any director or executive would be to not take any risk and apply all the best practices that we know. We are fortunate enough to work now and live in years after all this internet started to exist and all the software and web software development started to exist. So we do have plenty of practices that we have learned through others' experience. We have practices, we have tools, we know exactly what to integrate and where. The only thing we need to do is to make sure that we do not cut corners just to save money on the short term, assuming risks that may lead us on medium and long term to bad consequences, which can be even the bankruptcy of the company. Depending on the size of the company, such an incident can even lead to the bankruptcy of the organization.
That's a good point. Before we get too far ahead, right? Let's talk a little bit more about the book, because writing a book is not simple. How do you how did this book get started? Like, where was the idea coming from?
So the idea for this book particularly wasn't mine. It's my friend's Adib, who I'm co-authoring the book with. He started the book a few years ago, but he's a really busy guy. He's also an expert in software security and particularly in Java and Spring technologies. And he started with this excellent idea. He put in practice and wrote a big part of the book, but then he asked for help. So I've started with some of the chapters, and I continued the book and tried to put it now in place. The book is still in early access. It will be hopefully printed soon. I have just finished with the last chapter, and I'm working now on the final touches. And the idea of the book is to put there all essentials a software developer should know about security. The book indeed has examples with Java and Spring and is more on the backend side, because Adib and we are both backend developers at our core and Spring and Java developers at our hearts. But the subjects that we are describing, they are, from my point of view, valuable for any developer, whether it's a backend developer, a mobile developer, a front-end developer of any kind. We talk about cryptography, we talk about standards, we talk about tokens, we talk about frameworks and protocols such as Auth2 and OpenID Connect, and different ways in which authentication and authorization appears at the system level, and where should be and where can it be done, and which are the consequences, the compromises an architect makes when they choose one solution or the other.
Okay. Yeah. I mean, I'd like to get more into kind of the content of the book, because you have a lot of interesting ideas that you go over into it. One of those, which I think is quite important, because it's been, I'm guessing you probably heard of this before, but I've heard people talking about like Google and stuff getting rid of passwords, right? And people say, well, how could you get rid of passwords? I have seen in the past, I don't know, what is it? For sure, 6 months, like 3 months, I feel like there's been a big push from people to really push having passkeys, right? Which is basically, my understanding is it's based on like the WebAuthn. Am I right? Is it the same thing or no? Because it's the same. Okay, yeah, because it's pretty interesting. Like that passkeys is something that is, how do I say? I mean, it does help you get rid of passwords, and it's super safe compared to other things. I would like for you to kind of talk a little bit about WebAuthn and passkeys, because it's probably something that people have heard of or maybe seen before because of the recent pushes from big companies. And maybe it's good to kind of hear more and more about it and how simple it is. Well, hopefully how simple it is to add to your app. Something that I'm looking to add, but it's something that people need to get used to first, and I feel they're not quite there yet.
Yes, clear. So first of all, I want to mention only having a set of credentials for authentication today is not enough. So wherever you authenticate, whatever you use, whether it's your YouTube account, your Netflix account, anything should have more than one authentication factor today, because a set of credentials, well, there are so many ways someone can get their hands on your credentials without you even noticing. So having only a username and the password is not enough. That's why you will see the majority of the systems today ask you to authenticate with more than the credentials. They add at least a second factor, and that's what we call multi-factor authentication, or shortly MFA. The easiest way to apply MFA, you might know it, is having your phone number and receiving an SMS with a code, or using a specific application on your phone like Microsoft Authenticator. You have a code there, it changes every minute. You have to introduce the exact code on your mobile phone to prove that it is indeed you and not someone who stole your who've stolen your credentials. That's a must. Now, there are many ways in which we can apply MFA. So the most common, probably, it's still the OTPs, one-time passwords. Now, the OTPs is the name we give to the codes that we use after we put our credentials, and that we either receive on an SMS or through another mean, an email, or maybe an application such as Microsoft Authenticator. This is the easiest, but we have other options, and the one that you have suggested, Ellen, is the most secure. So WebAuth, what we used to name it, is a framework. It's a standard that defines the ways in which you can authenticate on a system using either biometric ways or hardware ways. A biometric way, so OTP is good. No, I'm coming back to OTP. Is good because how does it prove that it is you who added the credentials? It checks that it's something you have with you. So you have first registered your mobile phone, your smartphone, no, and the system now relies on the fact that if you have the correct credentials and also own that particular smartphone that you have registered, then it means it is you. At least these two factors, they prove that it's a better chance that is you, because otherwise it assumes that someone knows your credentials and also somehow they've stolen your phone. Going with a WebAuth, which is even better than OTPs, no, this framework ensures the usage of biometric authentication and hardware authentication. Biometric authentication is something not that you have, but something that you are. No, the second authentication step is relied on either something you have, like your mobile phone with the OTPs, or something that you are. And in the case of the biometric authentication, is something that you are. It can be your fingerprint, for example. We do use it quite a lot today on devices, and it could be even other more fancy ways to check that you are based on biometrics, such as the VIN or your iris and so on, which are less common, at least not in the, let's say, day-to-day use. And we also have something that you have, the hardware key. What is a hardware key? It's something that you have with you, hardware. No, you keep it with you. It's usually something that looks like an USB stick, and that you can plug into your system that you want to authenticate with. you pre-register it, and then you can use it to plug it into what you have registered for authentication. You plug it in and the system recognizes you. This way, only if you have that hardware key, only in that case you can authenticate. And you can use the hardware key, of course, as the first step, but in many cases we use it as the second step, which is the second factor of authentication. So you still put your credentials and then you have to plug in your key, and then if you have that key and you also have the credentials, it means that it is indeed you. The hardware key is more secure than having than receiving, for example, an OTP via SMS or email, because receiving an OTP via SMS or email implies that if someone, for example, they didn't steal your smartphone, but somehow they went in the middle. And you can do that with both email and SMS messages. They don't need to have your physical phone. They can still get that code and they can still authenticate and trick the system and impersonate you. But the hardware key is something very it only has one capability. No, it's not communicating with anything outside. It's not like your smartphone that receives the SMS via some network or receives the email via some network that you can intercept and man in the middle. The hardware key doesn't work like that. It's a very simple device. You have it, you can plug it in and you can authenticate. You don't have it, then you cannot do that. Of course, the downside of hardware keys is that if you lost it and you don't have a copy for it, well, then it's a little bit more tricky to get back into your system. But it's more secure from the point of view of the authentication.
Yeah, and I know there's been a big push with like the latest major iOS version where it's like they've integrated the, what do you call that, with the pass key where you scan it and it uses Bluetooth to connect to your computer in case you're doing this over a computer, and then I think you probably do like maybe type in a passcode on your phone or scan your face. That's pretty big one. I know some password managers also have the ability to do that. Then I think you can probably end up sharing your pass keys with people in case you want to log into the same account. Yeah, it's really a great technology that I think is far better than, like you said, you've already pointed out about OTP with passwords and emails and stuff. It can be picked up, right? I mean, the other one it could be is like the time-based one where you have like Google Authenticator that gives you a code every, I don't know how long it is, maybe every minute or 30 seconds. That's another way to do it. Adding this stuff into your app, I mean, is that a complicated process? Is it you need to like register with some authority, or you just have to have the right libraries, or you've probably done it before, right?
Yeah, no, in most of the cases it's pretty straightforward. So that's why my recommendation as a software architect and security guide to all the developers is that they take this into consideration from the very beginning of the software they are building. Mainly, we have frameworks and libraries today for anything we want to implement like that, and in some cases, it might imply a cost, for example, because if you want to send SMS messages, then you have to probably use some kind of cloud service, software as a service, such as Twilio or AWS, SNS. But you still have an easy, from the development point of view, an easy approach to do that. In terms of hardware keys, this is also straightforward. Now, as we've said, we have a framework, we have a protocol in place. We only need to use it in our software to implement either biometrics or hardware keys. With biometrics, it might be more difficult because you need, of course, a device that supports a kind of biometric approach, such as, for example, scanning your fingerprint. But if you don't need something fancy, as you said, you can even use your phone. Because I've said, okay, normally you have a hardware key which is small and you can plug it in. But today today people start thinking more about how can we use something that we already have in our hands as anything. And the whole idea of a hardware key is not necessarily that it has to be like only like a stick or something like that. The whole idea is that it doesn't communicate that code outside, so through a network, because that's where it can get intercepted. So when you would use, for example, your mobile phone as a hardware key, then it assumes that somewhere in its memory it has a cryptographic private key, and without communicating any code, that cryptographic key can be used to sign a message that would be recognized as being you. This is what we call an asymmetric key signature process. There is a cryptographic algorithm we call RSA that we use at the base of that. RSA or ECC, we have two of them mostly used today. And what it does is it's proving through some mathematical ways that it is you who you are by having that specific device, but without having to have a code that flows throughout the network and can be stolen. So that's the idea. To implement all this today, we have plenty of libraries. I am mostly experienced, as you know, with Java and Spring, but I'm pretty sure all the platforms out there, whether it's Python, .NET, JavaScript, or any other language or ecosystem, you name it, it has enough things in place, because these are for us fundamentals. These are part of the foundation today that we use to build software. Security is part of that foundation. We are now usually conscious enough that besides the functionality, that's the capabilities that we implement in a software, which we call the functional part, there is also these non-functional requirements that an application should have. And one of the most important non-functional requirements, as we know, is the security. And that's why the majority of the frameworks today, I would say all of them, provide you with everything you need to implement cryptography, authentication and authorization protocols, tokens, and everything else you might need. So I know security sometimes has created this image of being complicated, and it is. I cannot say it's a simple subject, but it's not as complicated as it used to be, because now you have tools that help you with everything. No, today you don't have to use the axe anymore to cut down the tree. You have a chainsaw with any ecosystem that you can use.
I was just thinking, like in general, having those like YubiKeys or these other kind of hardware devices to kind of log in with, or people forget those. Like I have one right now, and I'm always like, what if I forgot it? And I think they actually help me to program something that's similar to it on my phone. But in general, like using somebody's phone to authenticate is like definitely one of the best ways to do it, because no matter what, like, everywhere we go to the washroom, we have it. We go wherever, we have it. We almost never forget our phone. It happens, but compared to the hardware key, like it's not even close. This thing's always on our hip.
Yeah.
We're always playing around with it. So having that is the only thing that sucks, though, is if you run out of battery. Then that's the hard part, right?
True. And that's another advantage. You also have the capability to usually easily port a data from one device to another in case you lose it through a cloud. That includes your keys, but pay attention, that only happens. So you should do that only when you change your phone, because I know you either upgrade or you have lost your phone. Don't do that like just for fun, because playing with private keys then can be risky. The whole idea of private keys is that they shouldn't move. When they move, they are exposed. So they are exposed to a risk, the risk of being stolen. But yes, as you said, comparing to having that simple stick that of course has the advantage of not needing a battery and being so simple. It's almost impossible to crack it. It's like really like that hardware key you were using to unlock the door, no? But if you have that kind of a stick, the best practice is you always need to have a copy of it, because it might happen that you lose it and then you are in trouble. In case of a phone, it's a little bit easier. If someone steals your phone, then you still have usually options that Apple or Google provides you with to regain control over what you had.
I'd like to talk a little bit more about authentication. Authentication is really the first step, because without authenticating who you are, you can't do the authorization. We were talking before the show about OpenID Connect, right, and how it's built on top of OAuth 2, and how we should be using PKCE. I know this already, but I'd like to hear this more about from you, because as Flutter developers, we should be using OAuth as a way to authenticate, or at least definitely consider it highly. And when you do use OAuth 2, you should be using PKCE. PKCE, it's pronounced it's written PKCE, if I remember correctly, not PXIE,
Yeah.
like maybe some of the people may be thinking. Do you mind to kind of talk a little bit about OAuth 2? What is OpenID Connect in relation to that, and PKCE, and how this stuff kind of fits together?
Yes, clearly. So first of all, years ago we were using authentication as an independent mechanism implemented by each application, which was fine up to a point, because when internet it grew, and it really started to become a thing, you suddenly now have like maybe hundreds of sites, or at least dozens of websites and web applications that you use daily to order food, to order stuff, to listen to music, to watch videos. We use plenty of them. I don't even know how many I would have to count myself. Well, it becomes problematic, because if each and every one of these would have to manage their own set of credentials, well, you would have your set of credentials in each and every one of them, and then you would have to log in through a different mechanism every time. So things evolved into a way in which, in the majority, to make things easier, they allow you to authenticate with the same set of credentials you use on a particular typical used application to multiple. So you can, for example, log into Spotify using your Facebook credentials, or you can log into Amazon using, I don't know, your X credentials. This is done through separating the authentication into a different system that we call identity provider or authorization server shortly. Good. So now the problem is that you do authenticate not in the app that you use, but in the identity provider. So it's the identity provider where you log in and eventually put a multi-factor authentication in place as well. And then what this identity provider does is issuing a token, which is kind of an access card, giving you I say you, it's the user, but it's actually through the client application you are using. If you use a mobile application, the client is the mobile application you use. That mobile application takes the token obtained after you successfully authenticated, and it uses that token, which is the access card, to identify and grab the details from the backend side, the details that it needs to serve you. This sounds easy, because it's basically in the top of the mountain. You think it's just like you go to a corporate building, you identify yourself at the reception using your ID, and then you get an access card, and suddenly you can use some of the doors. That some of the doors is the authorization part. We leave it aside. But the problem is that there are many ways in which this token might be stolen if you keep it in this simplistic way. So what OAuth2 does is the specification describing in detail how should you implement flows such that you don't have vulnerabilities in your applications, vulnerabilities implied by the way these applications communicate, talk with one another. That PKCE is basically a best practice that I would say, we need to use always, especially with mobile application. PKCE it actually stands from proof key for code exchange. That's PKCE. And it's basically, it works like this very, very quickly. So it's when the client, the mobile app, wants to ask you to authenticate, to put in your credentials, it generates a random piece of data, something random. So just imagine it's not a number, but you can imagine it's a number if it's easier for you to imagine like that. And then over this number, it hashes, it applies a cryptographic function that gives you a result that you cannot turn back into that number, but you can always validate that the number generated that hash if you have the hash and the number. So it sends the hash over the network, and if someone would be in the middle and intercept the hash, it's just some digested, we call it's digested data. It means that you get it, but you cannot do anything with it. There is no mathematical way to get back from the digested data into the input that created the data. So that makes this digested data very secure, no? Because even if someone steals it, is nothing they can do with it mathematically. They cannot simply just guess the random data, or they would still just have to guess the random data, which today is not possible. It will maybe at some point be possible when we have quantum computing everywhere, but now it is not. So the client sends this digested data and asks you to authenticate. You authenticate, and then the identity provider provides back the data, provides back an answer saying, yes, this user indeed, they authenticated it correctly, they are valid, but now I have to give you an access card. So the identity provider only tells the client that you correctly identified, but it doesn't yet provide the access card. What it does instead, it tells the client, now, if you want me to give you the access card, please send the random value, the clean value that was used to generate the data. And because only that client knows that value, only it can now ask for the token, for the access token back. And that's basically a way to protect this communication, to make sure that no one can stand in the middle, in between you and the provider when you authenticate and then steal the access card. The only way someone would be able to get the access card is to know that particular random piece of data that has been generated in advance. But they cannot know that. They could only guess that, but we again consider that impossible without quantum computing. So because that never actually went in clear away from that from the client, only the client knows it. So only the client can prove who they are to get the access card, the token, know the access token, and then use the token to operate with the data on the backend side. And that is, in, let's say, a simple description, what we call PKCE, proof key for code exchange, meaning a key you use to prove who you are when you exchange, when you get the access code, the code exchange. That's what it stands for. And it's something that you should always have, especially with mobile applications. Even if it looks like it overcomplicates the flow, well, it does complicate a little bit the flow, but it adds a lot of security. It really ensures that no one in the middle could steal your data. And of course, above this, all this protection that we have, remember always when we discuss about communication over the internet, everything should be done over what we call TLS, which is basically what gives you that S in HTTPS, that's secure in HTTPS, meaning that anyway, today, all the communication over the web, over any network should be encrypted. It is encrypted. So someone trying to steal this data would now have to go over the HTTPS encryption and then over the PKCE that helps secure even further. And now you can see how these together, they help you basically making your communication bulletproof. This is how security works in general. I do always imagine security as being multiple walls one after the other, but all the walls may have holes in them or different vulnerabilities. No, but if you have multiple of them, each of the next wall basically enhances what the previous couldn't. So then if you follow all the best practices, you end up with something that you cannot step through. And that's how we think about security today.
We talk about this happening over a secure channel. You have a separate section within your book about TLS. I believe TLS people, if you talk to them about it, they may not know what it is, but something that we actually use all the time. Like when you go to almost any website nowadays, you have HTTPS, which is HTTP with TLS on it. Do you mind to kind of talk a little bit more about why we should actually use this? Because it's not hard to spin up a web server that just serves traffic over HTTP. People they don't quite understand why we need to have HTTPS and what's the point. Can you talk a little bit more about that?
Well, I have kind of a funny story. No, I've been in the times where TLS wasn't a thing. So I've been living the times when a lot of websites, even for big companies or even public administrations, were using HTTP only. And it's even at some point messenger applications, they were not protected over SSL and TLS. And I remember sometimes when I was in school, I was using a network sniffer. It was called Kind and Able to trick the other computers in the network, pass all the information through me. This is actually called the man in the middle. So I was directing all the data through me and back and intercepting the data. And because many of the things didn't use any encryption, I was basically able not only to read, but also to change this data if I really wanted. Of course, to read it was the most valuable to me. This is such a simple concept based on how the internet works. So in a local network, if you change what is called the ARP table, you can trick the switch you connect to the network to believe that you are actually the router, which is the gateway to the internet. So what you do basically, you trick the switch, or you trick the other computers to believe that you are the router. They send the information to you, and then you can send it further to the router and then receive it back and send it back. So you suddenly are in the middle of the communication. This is basically not possible now, or at least not that easy because of the TLS, but that really was a thing. So you can imagine what could happen at some point. Actually, you can even try it today, but what will happen is that if you try to access, even if you try to access the certificate that it's used wouldn't be valid. So anyone will try to trick into. They will observe that. If you look at your address bar, now all the websites usually have this padlock. That actually means you are under HTTPS, and that is good. And one thing that usually you should do whenever you are working from an unsecure network, so you say you are working from Starbucks and you're working on and paying something on the internet, okay, you are shopping and you want to pay whatever you shop, always take a look at your browser and make sure that you are on HTTPS. And then you will ask me, why aren't we now always on HTTPS? Well, you will be surprised, but there are still ways in which people can be tricked, especially on public networks. I will tell you now only one of them, and very quickly, because it's not like an easy to detail topic. But what one can do is to replicate, for example, a known website, and then what they can do is change all the communication from HTTPS to HTTP on purpose. So if you don't look, today browsers, they usually tell you that you are not secure. They make you attentive. But if you are not attentive in the end, or maybe you don't know what to look at, you might be tricked into giving information or unwanted information to people that can use it in bad ways. For example, you can put your credit card details there, and then instead of buying whatever you want to buy, you just gave your credit card details to whoever can then use them to steal your money.
If I remember correctly, like I'm not sure if this is still the same thing right now or not, but I believe that pictures and some assets on the website, I believe, can be served over a non-secure connection, but I could be wrong. Or maybe it's something that starts getting worn recently.
Yeah, what can happen is that pictures and data that is say bigger, no, it has more megabytes, sometimes might be served unsecure because of the performance like improvements developers want to make. Now it might be good or bad. It's not necessarily bad. Sometimes these images are public anyway, so it doesn't really matter. They are served in an unsecure way, but there are cases in which this might matter. It depends on specifically the case that we discuss.
Something else kind of interesting too is I believe for the most part, DNS queries are not secure. So whenever you search for something, people can actually see that it's not over a secure connection unless you're using like the newer protocol, which actually goes over TLS. Am I right?
Yeah, or unless you are using an onion protocol, know that it's what we use when we search on the dark web. But I think that's another story.
That's not me.
So yes,
you said we, but not me. I'm not sure if you're on the dark web, but not me.
Not me either. Never did that. You're totally right with the DNS, and now it's probably something that doesn't really harm you unless you may be thinking about your privacy. Can someone trick the network to find out what are you accessing? Yes, there are ways. There are easier ways they can do that than, for example, intercepting the communication itself. Because this DNS, what it actually does, it actually changes a name that you usually use in your browser to an IP address, which is basically what the computer needs to be able to talk over the public network. So you have google.com, but the computer doesn't have any idea what google.com is. It has to exchange this to an IP address, which is basically what it understands, what it can use to find out where the Google server is and then provide you with the data. And to do that, it uses servers that we name domain name servers, which are the DNS now. And the communication to a DNS is not encrypted. So that means that someone knowing how to intercept your network might see if you are searching for I don't know what kind of product you need. You are searching for something, and then the fear is that some applications or some systems might use this data to provide you, for example, with unwanted commercials. No, that could be a case, because if you can intercept what kinds of websites or domains the users searches on, then you can have things that then pop back with advertisement exactly on that. Now you are searching for a shovel because you want to plant a tree in your garden, then you suddenly see only shovels on the internet because you did that. You searched for a shovel. An idea just.
I did want to talk a little bit more about TLS, right? It is like kind of the background of HTTPS. That's what the S is in HTTP. I did see you talk about that in your book. Most of our connections usually go over that. But a lot of things people don't think about is that you can basically add TLS to almost any kind of connection. Well, I've added for microservices. So when I talk to each other, there's TLS in between. I've also added it to like a database connection. So that way from my app to the database, we have a nice like TLS connection. But another important thing too is that TLS, I may be wrong, right? But you talk about this a little bit in your book. TLS is kind of like a one-side trust. So like when you go to, easy way for anybody at home to see this, you go to a website, you'll see that there used to be a green lock on Windows. For Chrome. You would see that it's a great connection, it's verified. You don't really see that anymore nowadays. I'm usually on a Mac, so I don't know how it is on Windows nowadays. But in general, when you go to a place that has a unverified certificate, right, which is the website saying, this is who I am, it'll come up as red and say, are you sure you want to go here? It's a danger, right? What I did want to talk a little bit about is kind of talk a little bit about, the TLS and that one-sided connection. And the other thing too is you mentioned in your book, which is great, mTLS, which is the mutual TLS. It's a way that you have to both prove who each other are. Can we talk a little bit about each of those, how they kind of work, and then also why you would choose one over the other in certain situations?
It's a very good question. Yes, indeed. When we talk about TLS, we usually refer to what 99% of the cases TLS is used for, which is what I was saying earlier, what's behind HTTPS and communication over client-server communication over the internet. That shortly, I said it relies on encrypting the communication. It's a bit more than that. You need a certificate. You were actually mentioning that certificate earlier, so I want to explain a bit more what that certificate is first, and then jump into the mutual TLS, the mTLS. So that certificate is something that you, the owner of an application, so if I create my own website, or my own web application, name it whatever you want. If I want to ensure all my users that it is me, it is my website, and not someone who tries to impersonate me or tries to impersonate my website, then I need a certificate that can be verified by the browsers. So that when someone accesses my web application through a browser, the browser checks that certificate, and if that certificate is real, is valid, it says yes, this is indeed the real site you wanted, this is a valid site, a site that proved, and we know who it belongs to, and so on. So there are some details linked about the owner to any of the validated websites or web applications. To do that, you need to access a certificate authority. What is a certificate authority? It's an organization where you can buy certificates, and what you buy is actually not a certificate, but the service of validating who you are, which ends up with a certificate that you can use on your website. So you go to them, you validate through different means who you are, and you validate that a given domain belongs to you. And once this process ends, you get a certificate, you can plant it on your web application, and then your web application will be recognized by all the browsers in the world, giving the user the comfort that it was a website or a web application who was verified by a recognized authority. That works one way, as you say, because it's only the client verifying the server, no? But then the question is, can you apply a similar verification, a similar validation in between two applications on the backend side? That's what we need today, because many of the systems today, at least all those that are very big, they cannot be made only as one single process. They are always architected as service oriented, meaning all the logic behind the scenes is not implemented in only one application, but in sometimes many applications that communicate with one another, such that each of these applications have their own purpose, and then when they need one another, they talk with one another to process the data in the certain way. This is needed because, again, some of the systems today are so big, such as social networks or Uber or something similar now, that has millions of users and serves so many requests simultaneously. It wouldn't be possible to run them as only one process on only one machine. So there were different tactics needed to give scalability to these systems. And that's how we ended up with these architectures that ensure us possibilities to scale the applications such that they can serve all these users. But now, what is the security risk? The security risk is that you now have services somewhere there that talk with one another to process your data. So then the question is, should the data also be secured in between the services? The answer is, in most of the cases, definitely yes. And then here is where we also have different ways to secure the data. Usually the data in the data in communication is secured using mTLS, which stands from mutual TLS, which is a TLS which is TLS, but rather than the one that we were discussing with the browser and the server, where only the browser needs to check the things. Now each of the services, they need to validate one another. That's why we call it mutual TLS. It's bidirectional. So then each of them needs to have a certificate, and each of them, when communicating, when talking to one another, will have to check the certificate of one another. So this way, each of them ensured that no one stepped into the system, created some application in between that impersonate one of the services, and then can steal or change data. So mutual TLS is indeed less seen, no, because it's only somewhere down below in the service communication, but very important today, especially when securing large systems.
It's super important. And cloud services usually, I think, did a lot of work for that too. Like I remember when I provisioned a Postgres database, I believe that I don't remember if they asked me if I wanted that or not, but you can easily turn it on. And I remember that they had an unsecure and a secure connection, and you just download the certificate, use that, and then just connect like that. And then you can do like some kind of verify of who they are. The mutual DNS one, I remember I read that in a book, or sorry, mutual TLS, not DNS, mutual TLS. I read that in a Go book about microservices, how you do it, and even how to like rotate certificates. It's a little bit of a trouble, but still, I think, like you said, it's worth it for for the long run. We have talked a lot about kind of the core pieces of how to start to secure your application. Do you have any kind of parting thoughts before we head off?
Yeah, thank you very much. It was a great time talking, and especially about one of my favorite subjects, security. Final thoughts. Regardless if you are a developer, an architect, a CSIO, a director, a tester, regardless of the role you have in building software, remember that is part of your responsibility to ensure the security of the system. So don't overlook it. Don't live with the impression that it's always someone else's responsibility to ensure that the apps or the systems are secure. It's all of us responsibility to do that. And if you see ways in which your application might be vulnerable in ways or another, or if you see practices that are not applied and you know they should, it is also your responsibility to mention that and to make sure that you make that visible to whoever is needed, such that the things are changed and applied correctly. Because with small things, we ensure that we eliminate bigger risks.
That's really important. These small steps definitely can help. We talked about before. Once you damage your reputation of being insecure with people's data, it's very difficult to come back from. Not impossible nowadays, but very difficult and costly in a lot of ways. It was great to have you on. Maybe I'll have you back on again in the future since you're a serial author, it seems. So just to remind everybody, the name of the book is called Software Security for Developers. Fantastic book. You cover a lot of things that I think every app should have when you're building all kinds of services. And great book to pick up. We'll have in the show notes a link to pick up the book. It's from Manning. If you're going to pick up the book, definitely pick it up directly from Manning. A little bit more money will go straight to the authors rather than if you buy it from Amazon. So again, thank you for coming on. And like I said, hopefully we'll have you back on again in the future.
Thank you very much, Len.